Good morning, all. Today, we'll be discussing about neural basis for Alexia and Agraphia. In the previous class, we discussed about the neural basis for language, and there may be some overlap because the concepts are very important. And to understand our day-to-day tasks like writing and reading, the neuroanatomy is very complex, and one should understand the neuroanatomy to understand the difference, the defects that can arise because of various disturbances in the circuits. If you look at the reading, that the visual component compensation of the language is very important. For reading is achieved by visual comprehension of language. Eyes, what they do is, the reading is achieved by visual comprehension of language. Eyes gather visual information and pass it through the visual pathways to cortical areas for processing. Both eyes participate in each visual field. For example, the right visual field, the right nasal retina and the left temporal retina, they control the right visual field. The left visual field, the right eye temporal retina and the left eye nasal retina control. That means for reading, the visual fields and the control mechanisms of these visual fields are very important. The left hemisphere decodes the written language for reading. So these, with few important initial comments, let us look at the gross diagram of anterior reading system, parieto-temporal reading system, occipito-temporal reading system. As I said, the visual information is projected to the thalamus, especially to the lateral geniculate body via the optic tracts, which I'll show you in the next diagram. From the lateral geniculate body, the projections go to the occipital lobe, especially to the visual areas 17 to 19, 18, 19. For visual processing via the geniculo-calcarine tract from lateral geniculate body to the occipital cortex, the geniculo-calcarine tract takes the information. What the visual areas does is they project a dorsal stream of vision information to the parieto-temporal region, the parieto-temporal reading system, and also a ventral stream of vision and to the occipito-temporal reading system. There's also an anterior reading system that is activated in silent reading and also in decoding infrequently used words. So with this visual information is coming from the lateral geniculate body and geniculo-calcarine tract, it goes to the area 17, 18, and 19, the visual areas in occipital cortex. The dorsal stream takes it to the parieto-temporal reading system, and the ventral system is occipito-temporal reading system. There's also an anterior system that is activated in silent reading and in decoding infrequently used words. So the reading is a complex task. As you can see, there's so many connections are involved. That's why in all the language or aphasia assessments, reading and writing are an important aspects of assessment. So one should know what are the disturbances that can happen in reading. So as I said, this is the eye, and the inner layer is the retina, and this is the outer layer is the sclera, and that you can see the sclera, and the optic nerve is conducting the impulses to the occipital cortex. So the visual fields, as a left visual field and right visual field, the left visual field is controlled by the left side nasal retina and right side temporal retina. The right visual field is controlled by the right side nasal and left side temporal retina, and the fibers are connected to the optic chiasm. From the optic chiasm, the optic tract takes it to lateral geniculate nucleus. From there, the geniculo-calcarine tract takes it to the occipital primary visual cortex. The point to note is the temporal fibers which are subserving the nasal region visual field on the right side. On the left side, they are not crossed in the optic chiasma. They go straight away. So both the visual fields and their connections are to be intact for reading from one side to other and from scanning. It's important in the visual system. The optic nerve fibers from the nasal retinas cross at this point of optic chiasm, whereas the temporal retinas do not cross. The optic tracts begin at the optic chiasm and conduct the retinal ganglion cell axons to the lateral geniculate nucleus of thalamus. 90% of these axons, they terminate here, and the remaining 10% project to the pretectal area and subserve the function of pupillary reflex in adjusting the iris diaphragm. The pretectal region of the midbrain is composed of 7 nuclei that make up the subcortical vision system. And this is very important for reading. Pupillary light reflex is the one part of it. The superior colliculus of midbrain is involved in the control of eye movements, so as the trochlear nerve, which I just said, the inferior colliculus. From the lateral geniculate nucleus, the geniculocalcarine tract projects to the medial part of the occipital lobe, surrounding the calcarine sulcus, which is the primary visual area, that is the Broca's area 17. The visual fields are received by the cortex in a contralateral fashion. Then for reading, the cortical processing of visual information occurs. What is this cortical processing? What does it involve? It involves handling the color, the location, the motion, the depth, and of course, identifying features of the objects at the same time. That's called parallel processing. Then the visual information is sent from Broca's area 17 to 18 and 19, which are visual association areas. So if you want to know where of vision, a dorsal stream of visual information is sent to the superior occipital lobe and inferior parietal lobe for further processing to detect where an object is located in the visual field in the context of reading where that particular word is located in the visual field. What of vision? A ventral stream for processing involves the inferior occipital lobe and the posterior and inferior parietal lobe to detect the identity of an object. Lesions in this stream may lead to an inability to recognize the object, that is called visual agnosias. They all have a connotation in reading. The reading, the cortical, what are the cortical reading areas? When we read a book, the words we read form a pattern. When we hear a friend speaks, we recognize the pattern of his voice. If a neighbor cooks, we recognize the pattern and can identify what is being cooked. So the inference is the posterior part of the brain is focused on recognizing patterns of auditory, visual, or olfactory patterns. This is called posterior heteromodal association areas. Humans have not always read when they were born, but as the ability developed, advantage is taken of the pattern recognition system, which is already there, which is built into the brain. So the pattern recognition is crucial in recognition. As one reads, one recognizes combination of letters. For example, the letters D, O, G pattern is recognized as dog, and a semantic meaning is attached to these lexicon. So there are 3 reading systems in the left hemisphere, 1 in the anterior region, 2 in the posterior regions. The posterior reading systems include parieto-temporal reading system, occipito-temporal reading system. The parieto-temporal reading system is the angular gyrus, that is Broca's area 39, Broca's area 40, the supramarginal gyrus, and the posterior part of the superior temporal lobe. This system, what it does is it focuses on word analysis. It does a decoding of words at the phonemic level, also involved in the comprehension of written and spoken language. When we do agraphia, this system will again come into vogue. The occipito-temporal reading system is located in the left inferior occipital area, left inferior posterior temporal area, and fusiform gyrus. This is the visual word form area. The visual word form recognition, or sight reading as it is called, and rapid access to the whole words. In addition, it integrates printed letters to their corresponding sounds. The grapheme to phonemic conversion takes place here. Grapheme is the written letter and word to phonemic conversation. How do you spell it? So anterior reading system, these are the two posterior readings which we just covered. The anterior reading system is Broca's area, the ventral, dorsal, premotor areas. This system is important for word analysis in terms of spoken language syntax and articulation. It plays a role in silent reading and in decoding infrequently encountered words. So during this talk, we come across frequently encountered words, infrequently encountered words, non-words, right? So this I'll try and differentiate while during the course of the lecture. So now the reading requires inferior frontal gyrus, superior temporal gyrus, and middle temporal gyrus. There are dorsal pathways and ventral. Primary motor cortex to superior temporal gyrus and medial temporal gyrus. This is one dorsal pathway which you can see. Broca's area 44 to superior temporal gyrus. That is another pathway that you can see. Ventral pathways at Broca's area 45, 47 to superior temporal gyrus, and frontal operculum to superior temporal gyrus is another one. So these are the various pathways. And you can see three of the pars opercularis, pars triangularis, and pars orbitalis, and the frontal operculum. So these are the areas which are very important for the language. And this is the premotor cortex. This is the inferior parietal lobe, IPL, which is another important posterior heteromodal association area. So this anatomy, you keep remembering, we keep remembering the areas 47, 45, 44, area 6, the premotor cortex, and 41, 42, and the 22, and area 38, the 22, 21 areas, and of course, remaining areas will get into that. So the oral production of language or reading requires the integration of pars triangularis, pars opercularis, pars orbitalis, and so four important things you should remember: the prefrontal cortex, left inferior frontal cortex, the supplementary motor area or area 6, and the primary motor cortex, that is primary area 4. So these are the areas which we are concentrating now. The articulation is especially the function of the frontal lobe and inferior frontal gyrus, and these areas which I have been emphasizing are very, very important. And to re-emphasize only, I have shown this. And this prefrontal cortex is connected to the limbic area also to add the emotional component to the language. So there are many functions of the prefrontal cortex: empathy, insight, response flexibility, and emotion regulation, body regulation, morality, and arousal communication, fear modulation, so this is a higher functioning cortex. This is a very important cortex, and it has got executive control function also. So the ideas of reading and writing, the concepts and the desire starts there, and other things. So what is the role of the prefrontal cortex? It's a wired for decision making. It is important. It's important for decision making. It is highly connected to the parietal, temporal, occipital lobes, also to the rest of the frontal lobe by way of the dorsal pathways, which include arcuate fasciculus and the superior longitudinal fasciculus. The emotional information, as I said, reaches from the limbic system via the thalamus. So a desire to speak originates in the prefrontal cortex. The thoughts are referred to the left inferior frontal cortex for semantic and phonological assembly. The prefrontal lobotomized individuals, they lack rational decision-making abilities and they act more on impulse. That's an important function of the prefrontal cortex. The left inferior frontal cortex is very important for a language is concerned. The motor plans for speech are located. The posterior dorsal part of the prefrontal cortex, which is an extension of the prefrontal motor cortex. Damage to this region leads to apraxia of the speech. That is, language is intact, but the motor plans cannot be retrieved and speech cannot be given. So syntactic comprehension and language production is a function of the Broca's areas 44 and 45 and pars orbitalis. The semantics, the verb selection, is a function of pars orbitalis and pars triangularis, and the phonology and pronunciation, the pars opercularis, is Broca's area 44. So these are the zones of responsibilities in producing or reading. The Broca's area, which is necessary for properly formed oral language, but it is not sufficient. It has to be networked with surrounding areas. So it networks with cortical, subcortical areas and is connected to the pars orbitalis, frontal operculum, insular cortex, and fusiform gyrus, etc. If there is a lesion just anterior to Broca's area, transcortical motor aphasia develops, and these people can understand others and repeat what is said to them, but they struggle to initiate speech, like in Broca's aphasia. So essence is Broca's area is necessary for expressive language, but is not sufficient. And for Broca's area 47 is for semantic retrieval, verb generation, judgment regarding whether semantic choices are acceptable or not. So a lot depends on the intactness of this area. And another important area is supplementary motor area. After semantic assembly in the anterior left inferior frontal cortex, the information is passed on to posterior dorsal left inferior frontal cortex for phonological planning and assembly. So where is this located? This language product is sent to SME or supplementary motor area, either directly or through the basal ganglia and thalamus. What SMA does, it then initiates the motor plans, and which is required for internally initiated activity of speaking. The SMA sends information to the primary motor cortex for the intended language production. So the primary motor cortex, the final responsibility lies with it. It sends the motor information to the speech muscles via motor speech systems, pyramidal, extrapyramidal systems, control circuits, and sensory feedback mechanisms. So either speaking or reading or it involves such a extensive neural circuits. What is Alexia? Alexia can be defined as an acquired disorder of learning. The pre-morbid reading skills are normal, but then suddenly there is a change due to stroke, head injury, etc., which disrupts the circuits. On the contrary, dyslexia means a developmental problem in acquiring reading skills, dyslexia. So there is a dual reading model. This dual reading model or dual root model for reading is also there for writing also. When we are discussing Agraphia, I will show you. There's been Russell in 2001 and Relay in 2017 that formalized this. So there are two routes here: lexical reading route, that is a sight reading of already known words, and non-lexical reading route, phonics. When the new words are encountered, the sounding things out, they read out. So there are two routes, and which you can see here, two routes. The dual Alexia dual reading model, the written word, we take an example of dog. First, when you look at the word, the visual feature analysis starts. That is, a D is a straight line with a curve to the left. O is like this. D. There are three sounds, and the letter analysis says dog contains three letters or sounds. Like whereas shoe has four letters but two sounds. Like that, the letter analysis starts, and then the lexical reading route, orthographic input lexicon. That is, it is already there, and semantic system and lexical non-semantic system will process this silent reading part. And then if you have to vocalize, then it enters the phonological output lexicon, the oral reading. And so, and then the phonological assembly takes place and the spoken word is generated. So this is the lexical reading route. The non-lexical reading route, there is a grapheme into phone conversion, phonemic conversion takes place. Then the phonological assembly takes place and word is spoken. So then when you enter the orthographic input lexicon, And then the semantic version is we understand the dog is a smallish, furry animal with 4 legs, tail, and box. So then we know that dog can be, the meaning can be attached to the dog. That's what we're doing in the semantic system. And we are pronouncing means we are giving some sounds to this inner meaning and generate the word, spoken word. So we will understand this. There are two basic forms, peripheral Alexia and central Alexia. The peripheral Alexia is because the reading problems are secondary to visuospatial attention problems. Visuospatial and attention problems. Here, there is a difficulty in matching the word seen with the word representation stored in the brain. You are seeing a word which there is a difficulty in matching it with what is stored in the brain. It's non-linguistic in nature and does not affect the underlying reading system. So this is peripheral Alexia. So there are two types of Alexias, peripheral and central. Peripheral has 4 types: pure Alexia, neglect Alexia, attentional Alexia, and visual Alexia. We'll differentiate all these 4 types of Alexias. So Alexia, peripheral, pure Alexia is what? Here, Alexia exists, that means difficulty in reading without a difficulty in writing, agraphia. So verbal Alexia. So patients can read, but it has to be done with a letter by letter, sounding out approach, the phonic approach using the non-lexical reading route. Reading is still possible, but it is slow and insufficient. The writing is intact, but they cannot read their own handwriting. So what is damaged here is the sight reading mechanism is damaged. There is a discontinuation between the visual information taken in visual analysis and letter analysis, and the left hemisphere word recognition system, occipitotemporal reading system. That's it. The peripheral Alexia or pure Alexia. Neglect Alexia is damage to the right hemisphere. The sufferers will fail to identify the initial portions of a word or a sentence as they try to read. There is a defect in letter analysis. What they do is they begin reading in the middle of the words or sentences. Familiar words are easy, but as they can predict them, but the non-familiar words are difficult to read. The other 2 Alexias in peripheral Alexia group are attentional Alexia and visual Alexia. The attentional Alexia is due to a damage in the prefrontal cortex, which mediates attention, as we all know. It is possible to read single words, but when encountered with multiple words on a single page, distraction and inability to read sets in. This is a failure at a letter analysis level. Visual Alexia is impairment in perception and analysis of the written words. There will be letter or syllable substitutions here. For example, butter is spelled instead of better. Here the problem is at the letter analysis system under the orthographic input lexicon. With these few words, let's go back to the visual feature analysis, the letter analysis, lexical reading route, orthographic input lexicon. They all are part of the peripheral Alexia. Central Alexia is the underlying linguistic reading system disturbance. There are 4 forms: phonological Alexia, surface Alexia, deep Alexia, and non-semantic reading problems. The central Alexia is different from the peripheral Alexia because it is underlying linguistic reading system disturbance. The phonological Alexia, surface Alexia, deep Alexia, and non-semantic reading. Let's see what are these. The phonological Alexia is due to a breakdown in the non-lexical reading route, and I'll show you again that dual root model. The dysfunction of a parieto-temporal reading system, where word analysis occurs, is the main problem here. What happens in this condition? The reading of real words is normal, but there's a problem in interpreting visually similar words. Night, K-N-I-G-H-T and N-I-G-H-T, like that. However, the main difficulty is in reading, sounding out new words also. In non-word, fope may be read as phone. So there's a difficulty in reading a new word, and unfamiliar or new words can often be misperceived as if they are known words. Like as I said, fope can be spelled as phone. So the phonological Alexia is this. The surface Alexia, there is a difficulty in reading words with irregular print to sound correspondences. There is difficulty in pronouncing colonel, act, island, borrow. So there is no difficulty in reading words with regular print to sound correspondence, that is state and hand, they can easily do that. But there is difficulty in pronouncing words with irregular print to sound correspondence. Where is the difficulty? Where is the dysfunction? Occipital-temporal reading system, which appears to be important in the lexical reading route. The deep Alexia, the semantic Alexia. Here, there is a breakdown both in the lexical and non-lexical routes. There is disruption of the occipital-temporal reading system, plus probably the perisylvian language areas. Here, the individuals recognize words as other words. Castle is perceived as night, bird as canary, misperceive similar looking words. The scale may be perceived as skate. The concrete words are better read than the abstract words. And an example of concrete words are chair and table. Examples of abstract words are fate and destiny. Non-words cannot be read due to breakdown in non-lexical route also. So these individuals are not aware of their errors, and they are not due to circumlocution due to word finding errors, but their real problem is there. So, and central and non-semantic Alexia, the reading without meaning. They can read real and non-words, regular and irregular words without difficult. However, they do not comprehend what they are reading. The pronunciation is correct, but they do not understand what they are pronouncing. There's a problem with the semantic system in the lexical reading route. The Wernicke's area and fusiform gyrus are affected. On the lighter side, most of the students, they go on reading without understanding the meaning, and a whole lot of us do this. Not that we are suffering from non-semantic Alexia, because we know that we can correct it once we look back. So you go back to the model here once again. Then a visual feature analysis, written word, visual feature analysis, the letter analysis of each letter in the word, whether 2 sounds, 3 sounds, and phoneme. The lexical reading route takes you to orthographic input lexicon, the semantic system, and the lexical non-semantic system. Then you go to, if you want to read out, you go to the phonological output lexicon, phonological assembly, which takes place in the anterior system. So this is the non-lexical reading route and phonological assembly and spoken word. So the areas that are important are already shown to you. Let us summarize the Alexia part of it. Peripheral Alexia is 4 types: pure Alexia, neglect Alexia, attentional Alexia, and visual Alexia. What is the definition of pure Alexia? Sight reading is impaired here. Visual feature analysis and letter analysis are defective or breakdown in the dual root model. Neglect is ignoring left or right visual fields. That means initial part of the word is missed. It's a problem in the letter analysis. Poor visual attention, letter analysis problem, attentional Alexia, and visual letter or cerebral substitutions and additions or omissions. And letter analysis system and also orthographic input lexicon. They are peripheral Alexias. The central Alexias, again 4. There's a phonological, surface, deep, and non-semantic. There's a trouble reading unfamiliar or non-words in phonological problems. And the problem in the dual root model is the non-lexical reading route. The surface Alexia is a trouble reading words with irregular print to sound correspondences. There is a lexical reading root problem. Deep is misreading of one word for another. Lexical and non-lexical reading roots are defective in the dual root model. Non-semantic, reading without meaning or comprehending semantic system in the lexical reading route. The non-semantic is what the most of the students sitting in the library do. They go on reading without understanding what they're reading. So this is the Alexia summary, and then we'll go to the written expression of the language, which is another important. When you start analyzing aphasia, you start with spontaneous speech output, visual and auditory comprehension, repetition, naming, and writing and reading, and which is given less importance, but a lot of things can happen in these both these faculties, reading and writing. So we have just read about the reading, the neuroanatomical correlates, and the types of Alexia. Now we are going to do what's written expression of the language. It's a unique human function. It relies on language abilities. It's a powerful skill to communicate ideas to people living in the same era or even after their death for future. So there are three processes involved in writing the language. The language processing and production are intimately linked with the skill of writing. What is the important brain area? Left inferior frontal cortex is involved in encoding. You require a motor control, which is necessary to manipulate the pen in hand in relation to the paper. And gross movements of arms and hands are to be controlled, as well as the fine motor movements of the fingers. A lot of motor control is required for writing, and there's also visuospatial involvement to guide in the three-dimensional writing space. You got a language, you got motor control, you got a visuospatial involvement and control. So the visuospatial elements are the left superior parietal lobe. The visual guidance of the hand and the fingers in forming the graphemes are the smallest units in the written language. What are the writing circuits? What are the parts involved in the writing circuits? The somatosensory association cortex, that is Broca's areas 5 and 7, are very important, which are surrounded by the primary sensory cortex, Broca's area 1, 2, 3 above, angular gyrus, that is Broca's area 39, and supramarginal gyrus, that is Broca's area 40, are situated below. And this area coordinates motor and sensory information, including the tactile and visual sensation. So the left superior parietal lobe and part of the somatosensory association cortex help in constructing the graphic images of letters. Just before and during the act of writing, one images what the letters look like. Left superior parietal lobe also directs the sequence of movements during writing. So these are the important aspects that can get disturbed. The motor elements are Broca's area and premotor cortex. The Broca's area 6 is adjacent to Broca's area 4 is important for the motor aspects of writing, and it's called Exner's area. So BS6 is called Exner's area, which is adjacent to the Broca's area 4, and it's important. The Broca's area 44, sorry. So what are the steps in writing? The desire and thoughts originate in the prefrontal cortex. They are sent to Broca's area for encoding. The language that is encoded thoughts are sent to the premotor cortex, Broca's area 6 and Exner's area, for handwriting motor planning. Then the motor plans are sent to the primary motor cortex. The primary motor cortex in turn sends the writing motor plans to the dominant hand. The left superior parietal lobe coordinates the visuospatial elements of writing. This is the broad concept. I'll give a more detailed explanation in the next slide. So you understand this. The desire and thoughts originate in the prefrontal cortex. They are sent to the Broca's area for encoding. The second step is that language encoded thoughts are sent to the premotor cortex, that is Broca's area 6 or Exner's area, for handwriting motor planning. The motor plans from the Exner's area sent to the primary motor cortex, and which in turn sends to the dominant hand with the writing motor plans. And what the left superior parietal lobe does is it coordinates the visuospatial elements of writing. So now we'll explain in more detail. The main brain areas involved in writing are Broca's area 44 and Broca's area 6, that is Exner's area, and the precentral gyrus Broca's area 4. Exner's area is anterior to the hand area, you can imagine. The graphemic images that are generated in the superior parietal lobe are sent to the Broca's area, which has extensive connections with Exner's area, Broca's area 6. And Broca's area is thought to organize the impulses from the superior parietal lobe and relay them to the Exner's area for conversion into graphemic motor plans. These plans are then sequenced in the supplementary motor area, that is Broca's area 6, and centropresental gyrus, which is Broca's area 4, which activates the muscle motor movements of the dominant writing hand. These are the language. You can see the origin of the concept and spread to the Broca's area. From there, the second step is go to supplementary motor area. From there to premotor cortex, and from premotor cortex to the muscles controlling the hand, and the superior parietal lobe, which is controlling the visuospatial aspects of writing. So this is a writing expression which we have seen. So agraphia is an acquired disorder of writing. Writing and spelling are crucial to skills of daily living. And agraphia can be more devastating if it coexists with the aphasia or Alexia. So in this class, we are only understanding what is agraphia. We are not going to discuss various other combinations. There is a dual root writing model also. This dual root writing model with lexical for spelling familiar words and non-lexical writing root for spelling unfamiliar words. So if your example is that on demand, you write dog. The meaning is attached to the head word using semantic system. Brain would search for a known written word in the orthographic output lexicon to match this auditory stimulus. And I'll show you this in the model. So next, this item will be sent to the graphemic buffer, a type of working memory meant to store this written word form long enough to write it. The allographic conversion stage, conversion into print or cursive writing and into the uppercase and lowercase as appropriate, takes place here. Graphomotor programming, the motor planning for the hand to make the correct motions with a pen or write. Graphomotor execution is the last stage in which the word is written. The non-lexical writing route accounts for writing words that are new to a person. And this mechanism used heavily in childhood as we learn to write and spell. So see how complex it is. And we have to really assess very carefully reading and writing in the assessment of our language assessments. So this is the dual root model. You can see the lexical reading route and non-lexical reading route, the semantic system, phonological output lexicon, and orthographic output lexicon, graphemic buffer, and allographic conversion, graphomotor programming, graphomotor execution to write and writing. So you can see the dog example, and which is non-lexical. It's a lexical reading route. There's a semantic system. The orthographic output lexicon is the storage, and this lexicon is stored, and we try and attach meaning to this, and we hold this graphemic buffer till we write that, and they convert dog into print, cursive or capitals, and lower case or uppercase as the requirement. And the graphomotor programming does how the motor plans on how to move the hand to write a dog, and then the execution follows, and that's what is writing. So this is a dual model which we see, and writing problems are known as agraphias. Agraphia is an acquired disorder of writing. The peripheral agraphia, central agraphia, two types, like peripheral alexia, central alexia. The peripheral agraphia is writing difficulty due to visuospatial and attentional issues, as in peripheral alexia. Here, the core linguistic writing system is intact, but other problems are there. Whereas the core linguistic writing system is disturbed in central agraphia, and the writing system is grossly damaged here in central agraphia, and we'll see what are the types. The four types on peripheral agraphia: graphemic, spatial, allographic, and apraxic. The graphemic agraphia means there's a problem in graphomotor execution of writing and spelling due to attentional problems, omission, substitutions, or transpositions creep in. There's a lesion in the left premotor cortex and left parietal lobe. Spatial agraphia means there's difficulty in writing accurately on a horizontal line. They may tend to write on one side of the paper or the other. That is due to visual neglect or hemianopsia. A defect in the graphomotor execution caused by damage to the right hemisphere is the common cause for this. Allographic agraphia, there are errors in allographic conversion of the lowercase versus uppercase letters. You see how the Smith is written. Smith should be either all small letter or capital, but here S small, M capital, I small, T small, H capital. So the allographic agraphia is there are errors in allographic conversion of a lowercase versus uppercase letters. There may be confusion of print and cursive script. The left parieto-occipital lesions are responsible for this. The last one in the peripheral agraphia is apraxic agraphia. There's a disorder of graphomotor programming. There are impairments in carrying out the motor plans for writing. They have difficulty in properly holding the pen correctly and will search and grope to write letters correctly. The main writing centers are involved, that is superior parietal lobe, premotor cortex, and supplementary motor area. The central agraphia, on the other hand, also has about 4 or 5 deep phonological, surface, and semantic. The deep agraphia and semantic agraphia are almost close. They are characterized by semantic paraphasia, substituting one word for another due to issues with the semantic system. In addition, there is a difficulty in spelling, especially homophones. If you want to spell night versus night, there is a difficulty. The phonological agraphia is a milder form, damage to the non-lexical roots, phonological output lexicon. The difficulty is in writing non-words or non-concrete words. That's pride. Pride is a non-concrete word. Spelling is also affected here. So both these conditions are due to damage to the language regions of the left hemisphere, that is Broca's area, Wernicke's, and supramarginal gyrus. The third one is surface agraphia. There is impairment in spelling irregular words. You see island, I-S-L-A-N, island, but spelling of regular words is present. This problem in orthographic output lexicon. Here damage is seen in the left temporoparietal region in the extrasylvian area. The semantic agraphia has a difficulty spelling homophones, which we have already seen. The defect is in the lexical writing root and semantic system. The one last one, there's a graphic buffer agraphia. There's a defect in graphemic buffer system. Individuals cannot hold written forms in their linguistic working memory long enough to write the word. The shorter words are easier to write, but as they require less graphemic. So this is a central agraphia. So if in summary, peripheral agraphia, graphemic, spatial, allographic, apraxic. In graphemic peripheral agraphia, the letter or cerebral substitutions, additions, or omissions takes place in the graphomotor execution in the dual root model, the place of breakdown. For the spatial agraphia, writing on a slant under including additional marks, and there's on a horizontal line, there is a problem in writing, and they'll write additional things on paper. The graphomotor execution defect is there in the dual root model. Allographic, there are errors in lowercase or uppercase and printing versus cursive. There's allographic conversion problem. Apraxic, motor plans for writing graphemes are lost, graphomotor programming. And in the central agraphia, there are deep phonological, surface, semantic, graphemic, semantic and deep are almost same. The semantic paragraphia, the substituting one word for another. Semantic system and orthographic output lexicon is defective in dual root model. The phonological trouble writing words. Phonological output lexicon is defective. There is inability to spell irregular words, that is surface agraphia, and that is island example. Orthographic output lexicon is damaged, breakdown. The semantic difficulty spelling homophones and semantic system. Trouble holding word form in memory in order to write, graphemic buffer. Short words can be easily written, but long words it's difficult. So in this class, we have gone through the dual root model for Alexia and Agraphia. Before that, we understood what is the neuroanatomical correlate for reading and writing, and that I think completes our language. We covered the dysarthria, aphasia, Alexia, Agraphia, and next class will be going on to the following part of this series. If there are any questions I'd like to answer?
Sir, in autistic children and ADHD children, they also have this kind of reading and writing deficits. So can we say that the areas in the brain which are responsible for reading and writing is affected in those children?
Yeah, depending on the areas, these are all network disturbances. They are dyslexias mostly. not acquired Alexias. So
Yes.
yes, there is these circuits will be disturbed, and you see how extensive these circuits are, and any disturbance can lead to this. And there's so much coordination is required, and the posterior lexical systems of reading and the anterior system. So the parieto-temporal and the occipital-temporal systems, they all to be intact. And if there is a defect, yes, attention deficit hyper. Attention is mainly the frontal lobe connections with parietal, temporal lobes and occipital lobes.
And sir, one more questions. In order to rule out that this area is particularly affected, we need to do the functional MRI, right, sir?
Yeah, but nowadays the concept is not particular area. It is functional MRI that way shows abnormalities in various places, not one particular area. That's the circuit disturbances. Yes, important to do functional MRI so that you know the circuits that are disturbed, which connections are disturbed, from where to where it is disturbed.
Okay, sir. Thank you, sir.
So if there are no more questions, and I think we'll go on to the next class on swallowing. Okay, then I'm going to end. If there are still questions,